Here we go with a new topic called maxima and minima of functions of two variables. Let f of x comma y be a function of two variables x and y, and let x is equals to a and y is equals to b. The function f of x comma y is said to have maximum or minimum at the values if it satisfies these two conditions, where h and k are small values. Is stationary value. F of a comma b is said to be a stationary value of the function f of x comma y if dou f by dou x is equals to 0 and dou f by dou y equals to 0. It means we are differentiating the function with respect to x, and if the differentiation is equal to 0, and that when we are differentiating the function with respect to y and its differentiation is also 0, then we can say that the f of a comma b is a stationary value of the given function, and that point is a comma b. And extreme values are nothing but both maximum and minimum values are known as extreme values. So f of a comma b is said to be an extreme value of the function f of x comma y if it is a maximum or minimum value. So extreme value nothing but both combinedly maximum value and minimum value is known as extreme value. Note, every extreme value is a stationary value. So the stationary point extreme values or extreme points can be the stationary values, but converse need not to be true. It means every stationary value cannot be an extreme value. And here we see the procedure of finding maximum and minimum values to the given function f of x comma y. So at first we find the dou f by dou x. It means we differentiate the given function with respect to x, and we also find the dou f by dou y. It means we also differentiate the function with respect to y, and we equate to 0. So dou f by dou x is equals to 0 and dou f by dou y is equals to 0. Then we get the equations and solve those two equations, and we get the pair of values like a1 comma b1 and a2 comma b2. So these points are known as the stationary points, and we get those points when we equate these differentiates to the 0 and when we solve those two equations. And the second point comes as find L, M and N, where L is equals to dou square f by dou x square, and M is equals to dou square f by dou x dou y, and N is equals to dou square f by dou y square. These are the second order derivatives. And at third, you have the conditions here. First we have to find out the ln minus m square. If ln minus m square is greater than 0, and if L less than 0, if the given lm and n value satisfies these two conditions, and at the point a1 comma b1, then the function has the minimum, it has the maximum at f of a1 comma b1. So at first we find this ln minus m square, and we check whether it is greater than or greater than 0 or not. If it is greater than 0 and L is less than 0 at the given point, that is a1 comma b1, then the function has the maximum. It means whatever the function is there, we substitute the given point in the function, and when we solve that, we get the maximum point or maximum value. And this second condition comes as ln minus m square is greater than 0 and L is also greater than 0. So at point a1 comma b1, then the function has the minimum, and that minimum value we get that minimum value when we substitute this a1 comma b1 point in the given function. And the third comes as ln minus m square is less than 0. At first, if it satisfies this condition, then no need of knowing the value of L. So at the point a1 comma b1, the function has neither maximum nor minimum. It acts as a saddle point, so it does not have any maximum or minimum point if it satisfies this condition. Then fourth point comes as if ln minus m square is equals to 0 at a1 comma b1, then we write a statement as no conclusion. So we shall solve one problem here. It comes as find maximum and minimum the function f of x comma y is equals to x cube plus 3xy square minus 3x square minus 3y square plus 4. So this is a given function. Let it be as equation number 1. So at first find dou f by dou x and dou f by dou y. So first we are differentiating the function with respect to x, that is dou f by dou x, and that equals to dou by dou x of the function f of x comma y. Then dou f by dou x is equals to x cube differentiation with respect to x, that is 3x square, and 3xy square differentiation with respect to x, that is 3y square. It means 3y square is treated as constant and x derivative with respect to x is 1. Minus 3x square with respect to x is minus 3 into 2, that is 6, into x, that is minus 6x, and minus 3y square with respect to x is 0, as there is no x variable in this term, and constant differentiation is always 0. Then dou f by dou x is equals to 3x square plus 3y square minus 6x. Similarly, we also derivate the function with respect to y, and that is dou f by dou y is equals to dou by dou y of the function f of x comma y. Then dou f by dou y is equals to this derivative with respect to y is 0, and 3xy square differentiation with respect to y is 3x into 2y, and minus 3x square derivative with respect to y is 0, and 3y square derivative with respect to y is minus 6y, plus constant differentiation is 0. Then dou f by dou y is equals to 3x into 2y, that is minus 6xy and minus 6y. This is a dou f by dou y. At the second step, we equate this to 0. So dou f by dou x, that is 3x square plus 3y square minus 6x is equals to 0. Let it be as equation number 2. And we also equate dou f by dou y is equal to 0, that is 6xy minus 6y is equals to 0, and let this be as equation number 3. So from this third equation, that is 6xy minus 6y is equals to 0, we can take 6y common. That is, if we take 6y common, and here x will be left over, and here 1, that is 6y of x minus 1 equals to 0. So 6y is equal to 0 and x minus 1 is also equal to 0. So that is here 6y is equal to 0 and x minus 1 is also equals to 0. And from this y is equals to 0, and from this you get x is equals to 1. Now substitute this y value in equation 2, you will get the values of x, and next you have to substitute the value of x in equation 2, then you will get the values of y. So at first we are putting y is equals to 0, it means this value, in equation 2. So when you substitute here, 3x square plus 3 of 0 square minus 6x is equals to 0. That comes as 3x square minus 6x is equals to 0. So from this, if you take 3x common, that is 3x of x minus 2 equal to 0. And from this, 3x is also equal to 0 and x minus 2 is also equals to 0. So from this, x is equals to 0, and from this, x is equals to 2. So when we are substituting the value y is equals to 2 in the equation 2, we are getting the values of x as 0 and 2. It means y with first x value and y with second x value. So the points comes as, we know the point, that is x comma y. So first we write the x value, and second we write the y value, that is 0 comma 0 is the first point and 2 comma 0 is the second point. So the points are 0 comma 0 and 2 comma 0 when we put the value y is equals to 0 in equation 2. And at second we have x is equals to 1. Now substitute this x is equals to 1 in equation number 2, and we get the values as like this. So put x is equals to 2 in equation 2, we get 3 of 1 square plus 3 of y square minus 6 of 1 is equals to 0. From this, 3 plus 3y square minus 6 is equals to 0, and 3 minus 6 is minus 3, and when it goes to the right hand side we get plus 3. So 3y square is equals to 3. From there we get y square is equals to 1, and then y is equals to plus or minus 1. It means y is having the two values as 1 and minus 1. So when we took the x value as 1, so 1 with 1 and 1 with minus 1. So the point comes as 1 comma 1 and 1 comma minus 1. So from this the points are 1 comma 1 and 1 comma minus 1. So we have solved those two equations and we got four stationary points. The stationary points or stationary values are 0 comma 0, 2 comma 0, 1 comma 1 and 1 comma minus 1. So at these stationary points we have to find whether the function is maxima or minima. So at first, before getting into those conditions, we had to get the values of L, M and N. So L, we know what is L, that is dou square f by dou x square, and that equals to dou by dou x of dou f by dou x. And now we are differentiating the function, that is dou f by dou x with respect to x, that is dou by dou x of the function dou f by dou x is 3x square plus 3y square minus 6x. Now 3x square differentiation with respect to x is 6x, and 3y square differentiation with respect to x is 0, and minus 6x differentiation with respect to x is minus 6. So you got it as 6x minus 6, that is the value of L. Similarly, M is dou square f by dou x dou y, and that equals to dou by dou x of dou f by dou y, and that is dou by dou x of derivating this function is 6x y minus 6y. Now 6xy derivative with respect to x is 6y, and minus 6y derivative with respect to x is 0. So 6y minus 0 is 6y. Then it comes to the n value. N is equals to dou square f by dou y square, that equals to dou by dou y of dou f by dou y, and that equals to dou by dou y of the function 6xy minus 6y. Now 6xy differentiation with respect to y is 6x, and minus 6y derivative with respect to y is 6. So n value comes as 6x minus 6. So now we have to get the value of this ln minus m square. So L is 6x minus 6 and m is 6x minus 6 minus m square. M is 6y whole square, and that equals to 6x into 6x, that is 36x square, and 6x into minus 6 is minus 36x, and minus 6 into 6x is minus 36x, minus 6 into minus 6 is plus 36, minus 6y whole square is 36y square. So when you solve this, 36x square minus 36y square and minus 36 minus 36, it comes as minus 72x plus 36. So this can be written as 6x minus 6y whole square minus 36y square. Or you can even directly write it as 6x minus 6 into 6x minus 6 is 6x minus 6 whole square and minus 6 square y, that is 36y square. You can take this as if base, or you can even solve by using this equation. So at first we are taking the first stationary point, that is 0 comma 0. So at the point 0 comma 0, ln minus m square, that is 6x minus 6 whole square minus 36y square. Now substitute this. This is nothing but the point x comma y. Now in the place of x substitute 0, and in the place of y also substitute 0. So that is 6 of 0 minus 6 whole square minus 36 into 0 square. 0 minus 6 whole square, this is 0. So minus 6 whole square is 36, which is greater than 0. It means ln minus m square is greater than 0, and L is equals to 6x minus 6, that is 6 of 0 minus 6, that equals to minus 6. So L equal to minus 6, this is the value which is less than 0. So L is less than 0. So by these two conditions, if ln minus m square greater than 0 and L less than 0 at the point 0 comma 0, then f of 0 comma 0 has the maximum value, and we get that maximum value when we substitute this point in the function f of x comma y. So f of 0 comma 0, that equals to, substituting those values here, you get it as 4. So therefore the maximum value is 4. Similarly, we also find for the second stationary point, that is at 2 comma 0. This is the second stationary point, that is 2 comma 0. So at the point 2 comma 0, ln minus m square is equals to 6x minus 6 whole square minus 36 of y square, and 6 of 2 minus 6 whole square minus 36 of 0 whole square. 6 into 2, 12 minus 6 whole square minus 36 into 0, that is 0. 12 minus 6 is 6, and 6 whole square, that is 36, which is greater than 0. So ln minus m square is greater than 0. Then now we find the value of L, that L is equals to 6x minus 6. 6 into 2 minus 6 is equals to 12 minus 6, that equals to 6. So where 6 is a positive number and which is greater than 0, that is L greater than 0. So if ln minus m square is greater than 0 and L greater than 0 at the point 2 comma 0, then f of 2 comma 0 has the minimum, that is f of 2 comma 0 is equals to 2 cube minus 3 of 2 into 0 minus 3 of 2 whole square minus 3 of 0 plus 4, and that value you get it as 0. When we solve, f of 2 comma 0 is 8 minus 0 minus 12 minus 0 plus 4, minus 4 plus 4 is 0. So f of 2 comma 0 is 0, and that minimum value is 0. Here we go with another stationary point, that is 1 comma 1. So at 1 comma 1, ln minus m square, that equals to 6x minus 6 whole square minus 36 of y square, and that equals to 6 of 1 minus 6 whole square minus 36 of 1 whole square, and 6 into 1 6 minus 6 whole square minus 36. So 0 square minus 36, that is minus 36. This is a negative value which is less than 0. So ln minus m square is less than 0. Now let 6x minus 6 is equals to, now substitute the x value in this, we get 6 of 1 minus 6, that equals to 6 minus 6, which is the value is 0. So if ln minus m square is less than 0, it's no need of finding L, because we got the first condition, ln minus m square is less than 0. So at this point we can say the point 1 comma 1, then f of 1 comma 1 has neither maximum nor minimum. So it does not have any maximum or minimum value. When it satisfies this condition, ln minus m square less than 0. And it comes to the fourth stationary point, which is the last one, and that is at 1 comma minus 1, ln minus m square is equals to 6x minus 6 whole square minus 36y square. Now substitute the values of x and y, you will get minus 36, and this minus 36 is less than 0. So ln minus m square is less than 0. So if ln minus m square is less than 0 at the point 1 comma minus 1, then the point has neither maximum or minimum value. So in this way we solve the given function when we have to find out the maximum or minimum values, and it is of two variables x and y. Thank you.